The image displays a handwritten note with mathematical equations and variables likely associated with a physics or engineering problem. Here's a breakdown of what's shown. 1. Diagram. There is a simple geometric diagram that includes a right triangle, indicating that trigonometric relationships might be relevant. The triangle is marked with points, possibly indicating positions or vertices used in the calculations. 2. Equations. The note involves calculations with derivatives, suggesting a dynamic system where variables change over time. It seems to be calculating a flux or flow of some sort, given by 2x flux. 3. Variables and expressions. X and z are variables, where z is defined in terms of x and x0 with additional scaling factors. The expression involves derivatives, such as frac dt and frac dx dt, indicating rates of change with respect to time. 4. Mathematical operations. The note includes a product and sum of derivatives, pointing to an application possibly in fluid dynamics, electromagnetism, or another field where flux calculations are relevant. Purpose. The calculations aim to establish a relationship or formula involving these variables and their rates of change, likely to solve for or model the behavior of a physical system. The specific context or application of these equations isn't clear from the image alone, but they are typical of problems involving dynamic systems where positions or other quantities vary over time. The logical steps in the equations appear to be consistent in the context of derivative operations, often used to find rates of change and relationships in dynamic systems. The usage of frac dx dt and frac dz dt implies calculations of how x and z change with time, which is a typical approach in physics and engineering to describe motion or other dynamic transformations. Analysis of logical consistency. Equation for z on. The equation defines z as a function of x and x0 scaled by some parameter b. This suggests that z is a transformed coordinate or parameter dependent on x and x0. Derivative of z though. The calculation of frac dz dt using the chain rule appears consistent. They correctly account for the derivatives frac dx dt and frac dx0 dt, assuming x0 is not a constant and changes with time, though often x0 might be constant, in which case frac dxt would be 0. Final expression. The final expression combines these derivatives in a way that aims to simplify or solve the initial setup of 2 times text flux. It's consistent in terms of maintaining the variables and their differential parts correctly aligned in the expression. Interpretation of x0 typically represents a reference or initial position in physics and engineering problems. It could be the starting point of a measurement or a fixed reference point in space relative to which x is measured. In the context of these equations, x0 seems to act as a baseline or origin from which x is evaluated. If x0 is indeed a constant, it simplifies the derivative calculations because frac dx0 dt would be 0. However, if it's part of a dynamic system where x0 also varies with time, then it correctly includes frac dx0 dt in the derivative of z. The logical flow in the note suggests careful consideration of the relationships and changes over time of the involved variables, aiming to capture an overarching dynamic behavior or flux in the system they are studying.